Hello everyone, my name is Omkar Gothankar and I am a second year computer science student at BITS Pilani. And today I'm going to talk about private, public and consortium blockchains in not more than 20 minutes. So let's go through what are we going to cover today. Firstly, we will talk about what is blockchain. Next, we'll talk about need for classification of blockchains. Then we'll talk about permissionless and permission blockchain. Also, we'll talk about public, private, and consortium blockchain. Next, we will cover the details, properties, and use cases of each of the individual blockchains. Okay, so let's start. What is blockchain? Blockchain is a shared immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. Blockchain based systems are often decentralized and have many real world applications. A smart contract is a piece of code that is stored on the blockchain and is executed automatically when certain conditions are met. So, what is the need for classification of blockchains? The distributed ledger of public blockchains is accessible to any person with an internet connection. In some cases, the data on blockchains may be sensitive and access to it needs to be restricted. Hence, depending on its use cases, blockchains are broadly classified into permissionless and permissioned blockchains, which can further be classified into public, private, and consortium. So, let's talk about permissionless blockchain. They are open networks which can be accessible to anyone with an internet connection. The data and transactions on these blockchains are transparent, and it is very easy to join as a validator in this network. Permissionless blockchains can either be public or private. Now, what are permissioned blockchains? These are closed networks where peers are designated members. It is partially decentralized but has a central authority. They need permission to validate transactions on this network. Also, they can be subdivided into public, private, and consortium respectively. So, now let's talk about the difference between permissionless and permissioned blockchains. Regarding access, permission blockchains approved members only, while permissionless blockchains are open and have transparent access. Permissioned blockchains are faster as compared to permissionless. The consensus mechanisms of permission blockchains is proof of stake or any other pre-approved participation. Permissionless blockchains usually have proof of work. The transaction cost in permissioned blockchain is low as compared to permissionless. Permissioned blockchains are also more scalable as compared to permissionless. Moreover, we have the network has full control over member access, and the same level for all participants is there in permissionless. The identity of each peer is known in permissioned blockchain, while permissionless blockchains are anonymous or pseudo-anonymous. Permission blockchains work in a trusted environment, while permissionless work in a trust-free environment. Permissional blockchains usually use tokens, which is not the case for permissioned. This is a Venn diagram which depicts the relationship between permissionless, permissioned, and public-private blockchains. In addition to what we have on the slide, we also have private permissionless networks and public permissioned networks. A hybrid blockchain is controlled by one single authority with some permissionless processes. Hence, we can see that it lies in the intersection between permissionless and permissioned. So, what are the differences between a private blockchain, a public blockchain, and a consortium blockchain? Regarding access, a single organization has access to a private blockchain, while anyone can access a public blockchain, while a consortium blockchain is managed and organized by multiple organizations. Authority in private blockchain is partially decentralized, in public blockchain it is completely decentralized, and in consortium blockchains it is decentralized. The transaction speed of private blockchains is fastest in all of the three, while it is slowest in public blockchain due to the numerous number of nodes. The consensus mechanisms in private blockchain can either be permissioned or permissionless, and similar goes for other two. The cost of setting up a private blockchain is high as compared to a public blockchain. Data handling in different types of blockchains is read and write for a single organization. This is only for private blockchain, while in public blockchain, read and write access is for anyone. In consortium blockchains, read and write is available for multiple organizations. Private blockchains are partially immutable, while public blockchains are fully immutable. Okay, so let's talk about the first classification of blockchain, that is public permissionless. So, what are they? They are open public networks and anyone can participate in validation of blocks. There is no central authority in such systems, and anybody can act as a peer and access the data on the chain. Few of the most prominent examples are Bitcoin, Ethereum, and Litecoin. What are the properties of public permissionless blockchains? A transaction can be easily viewed through block explorers such as the one at blockchain.com. The source code for such blockchains is open source and hence its development is also open source. Example, the development of Ethereum 2.0 is a massive open source project with people all over the globe contributing towards it. The peers in this network are somewhat anonymous as only the wallet address is visible in transactions. And there often exist incentives such as tokens and other digital assets in validation of blocks. Now, what are its disadvantages and advantages? Advantages. Decentralization in its true sense is achieved as the network involves numerous participants. As anyone can act as a peer, a blockchain cannot be censored or controlled by a central authority. Very secure as attackers would need to corrupt 51% of the nodes, which is hardly feasible. Disadvantages. Validation is not very energy efficient, as we all know that Bitcoin mining takes a lot of power. Very slow due to numerous nodes, as you know that Bitcoin can process only 7 transactions per second, while Ethereum can go up to 20 transactions per second. There may also be privacy issues, as transactions are publicly visible. Now, let's move on to private permissionless blockchain. What are they? Anyone can act as a node in these networks, but other nodes will only acknowledge its existence without sharing any data with it, at least initially. The smart contracts on this network also define who is allowed to read the smart contracts. This is achieved by creating an ad hoc chain every time the smart contract is deployed. A single node can store multiple of these chains, but not all of them. An example of such a network is Holochain, which gets rid of the shared hash and treats each transaction as an individual entity. Properties. The contract reading privileges are given not to nodes, but to specific individual or organizations. And to get a copy of the contract and the respective chain, you need the contract identifier and URL of node that has a copy. A node holds only the data it needs for service of users. Now let's talk about its advantages and disadvantages. Advantages. They are highly scalable because of the ad hoc chains. Disadvantages. Decentralization is somewhat lost because they are hosted on public servers. Also, there is no more anonymity in this network. Now let's talk about private permissioned blockchain. In these blockchains, only designated parties given permission by central authority can participate in validation. The data on this chain is visible only to authorized peers. An example of such a network is Hyperledger Fabric, which is a blockchain framework hosted by the Linux Foundation. It is a permission network that is used for developing blockchain based products and applications using plug and play components. Now, what are the properties of such a network? The transactions are visible only to network peers. They are developed by private entities and have a very specific use case. Example in supply chain management, where data on the chain is sensitive and cannot be disclosed to the public. The peers in such a network are not anonymous. There is single authority, unlike that in consortium blockchains. Now let's talk about its advantages and disadvantages. Advantages. There is a high degree of privacy in such a network. They are also highly customizable to specific use cases. They are very fast compared to public permissionless blockchains as the number of nodes is less. Disadvantages: decentralization of blockchain is lost. There is also a possibility of misuse of power by central authority. And as they are private, they are not transparent to outside oversight, and no one outside can know what is actually going on. And let's move on to public permissioned blockchains. What are they? Now, different public permission blockchains have different implementations, but in general, they fill the gap between public permissionless and private consortium networks. They inherit permissioning from private networks and combines it with a decentralized governance model. A few examples include Ripple and EOS. What is Ripple? Ripple is a permissioned network that is used to mainstream banks and payment processes. Properties of such a network are: the decentralized governance model improves the trust and confidence in the network, which is very essential. The benefits of permissioning are: better and energy efficient consensus mechanisms can be used. The network becomes easy to manage. Also, there is no need of cryptocurrency to incentivize miners. The transaction costs are proportional to those required to maintain the network and are hence relatively stable. Talking about the advantages of such a network, public permission network gets the best of both worlds. It gets decentralized governance from public anonymous blockchains and permissioning from private consortium blockchains. So this is a summary of what we have talked until now. If you divide the blockchains into architecture based on read, write, or commit permissions granted to the participants, you get permissionless and permissioned blockchains. If you divide it based on architecture, based on ownership of the data, then you get public and private blockchains. Now let's talk about them individually. Public permissionless. Anyone can join, read, write, and commit to such network. They are hosted on public servers and are anonymous and highly resilient. However, they are very low scalable. Public permissioned. Anyone can join and read in this network. Only authorized and known participants can write and commit. And they have medium scalability. Private permissionless. Only authorized participants can join, read, and write in this network. They are hosted on private servers and have high scalability. Private permissioned. Only authorized participants can join and read. Only the network operator can write and commit. However, they are very highly scalable. Now let's talk about the classification based on two dimensions, that is anonymity and trust. What is anonymity? Anonymity here refers to the anonymity of the user in the network, while trust refers to trust of the system. If you want a low anonymity and low trust network, you should go for private permissionless blockchains. While a low anonymity and high trust network is private permission blockchains, high anonymity and low trust is public permissionless, and high anonymity and high trust is public permissioned. Now let's look at the examples of the different classifications. Public permissionless, Ethereum, Bitcoin, Waves are a few examples. And these blockchains face the challenge of scalability and privacy. Public permissioned, sovereign, EOS, Ripple are a few examples, and they face the challenge of centralization and privacy. Holochain, LTO network, and Monet are a few examples of private permissionless networks. Also, they face the challenge of scalability and consensus. Finally, private permissioned. Few examples are Hyperledger Fabric and Enterprise Ethereum Alliance. The challenge faced by them is centralization and consensus. Now, moving on to the final classification, that is consortium blockchains. So, what are consortium blockchains? It is a permission blockchain where multiple organizations govern the network. Unlike private permissioned, they provide decentralization of authority as there are multiple organizations that manage the network. They also help The enterprises collaborate with each other. A few examples of such a network are Voltron and Batavia. Now, Voltron is a consortium blockchain which has an objective of digitization of documents and decentralized blockchain sharing. It involves 12 banks, of which a few are HSBC, US Bank, Bangkok Bank, BNP Paribas, and many more. Now, what are the properties of such a network? Consortium blockchains are easily scalable as number of nodes in the network is controlled. Also, there's no risk of 51% attack as each node is verified. As you cannot be anonymous in such a network, there is also no risk of criminal activity, and everyone can contribute to the network and get credits equally. Finally, let's talk about the advantages and disadvantages of such a network. Advantages: the participants are known, and hence there can not be any data threats. Also, as there are multiple authorities, no particular group can manipulate the chain like changing the consensus mechanisms or etc. There are no service or transaction fees in such a setting. Now let's talk about the disadvantages. There may be lack of cooperation between the network managers, which may affect the development and cooperation. They are not completely decentralized. Also, there is no unified framework for them to build upon. And that is enough for my presentation today. Here are a few links, a few references I used to make this presentation. In summary, I've talked about private, public, and consortium blockchains. Hope you liked it. Thank you.